So for our last video on quadratic formula, we are going to take a look at an application problem of a real world situation. And like most of the problems with quadratics, quadratics are really good for talking about things with like fluids and also with the way things move through air when they're acted on by gravity. So we are going to look at a situation, which I pulled off of Alex, a problem off of Alex, which models flight of something. So this is solving a world problem using a quadratic equation with irrational roots. And all they mean by irrational roots is that you're going to have something that's not going to be a nice, neat integer answer, because we know that if we have to take the square root of something that's not a square number, that's an irrational number. So that's going to give you an irrational root. So let's take a look at this. Ball is thrown from initial height of 5 feet with an initial upward velocity of 17 feet per second. That means that's what you throw it with when you release it. The ball's height, h in feet after t seconds is given by the following. So this is your equation. And the thing I always like to point out on these is if t is 0, meaning you haven't thrown the ball, the only number that's left is 5. So that means that you're throwing the ball from the initial height, which they show right here, you're 5 feet off the ground already. So, and why is that? Well, obviously the person who's releasing the ball must be, somewhere in the vicinity of, between, 4, 5, 6 feet tall and is releasing it when the ball is 5 feet off the ground. So for me, that would be about shoulder height. For some of you, that would be near the top of your head. All right, so that's what this means. And they ask us to find all values of t for which the ball's height is 9 feet. And so if you look at this problem, okay, they model it for you and they show you got this initial height that's going up like this. The ball's going up here. And then what's gonna, no, I didn't want that. And then what's gonna happen is it's gonna come back down again. So you have a parabola, right? Which the height here, the top height is gonna be, at some point, and then it's gonna travel down. That would be our vertex, and we could figure out where that is, but we don't need to do that. They say find all values of t for which the ball's height is 9 feet. So they want to say at what time is the ball 9 feet above the ground. So if you look at this, you're going to have 2 times when that happens. You're going to have a time when it's going up, so when it's about, right here, and then you're going to have it when it's coming back down again. So we should get 2 answers to this unless, something comes and grabs the ball before it gets there. So let's take a look at that. So the way you set this up is they're telling you the height is 9 feet. So we're going to plug that in for h. So you're going to get 9 is equal to 5 minus, or I think that's plus actually, yeah. 5 plus 17t minus 16t squared. All right, so we're going to probably have to use the quadratic formula for this. So let's move some things around and get this in our standard form, right? So we want to get this in ax squared plus bx plus c equals 0. So first of all, let's get the 9 over on the other sides. So that's going to give me 0 is equal to negative 4 plus 17t minus 16t squared because I subtracted 9 from both sides. And then I'm going to rewrite this as negative 16t squared plus 17t minus 4 is equal to 0. And now it is in that ax squared plus bx plus c form, all right? And one thing you can do with these that I want to show is if you don't like having a negative sign, you can always take this whole thing and multiply it by negative 1. And you can do it both sides. You don't have to really compensate because this is 0, and if you multiply it by negative 1, it's still 0. So you get 16t squared minus 17t plus 4 is equal to 0. So now we're going to take that, and we got negative a minus 17 because it's minus b. We're going to put this in our quadratic formula. Minus a minus 17, and we have plus and minus. And then our discriminant is going to be negative 17 squared minus 4 times a, which is 16, times c, which is 4. And it looks like this should work out because 17 squared is going to be bigger than 64 times 4, I believe. All right, and then put that all over 2 times a. All right, so let's do some simplification here. Negative 17 is going to give me 17. Plus and minus. Well, 17 squared is, I believe that's 289. All right, 289. And then minus 64 times 4 is going to give us 256. All right. And that whole works as over 32 because that's what 2 times 16 is. All right. And I'm going to see if I can move this down a little bit and give us a little bit of working room. Good, I can. All right. So the one thing I am going to do real quick is I'm going to make sure I did 17 squared right. 17 times 17. Yep, good to go. All right, so moving ahead here. So we got equals 17 plus and minus the square root of, well, what's 289 minus 256 gives me the square root of 33 over 32. So I'm gonna have 2 roots here, right? I'm gonna have 17 plus the square root of 33 over 32, and I'm also gonna have 17 minus the square root of 33 over 32. And sometimes with these, you'll want to look at that and say, well, if I subtract from 17, it's got to be smaller than 17 or I'm going to get a negative answer, and you're not going to have a negative answer for time, right? But this works out because square root of 33 is going to be a little less than 6. So let's figure out what this is, all right? So we go, it would be helpful if we knew what the square root of 33 is, all right? So we're going to figure out what that is. So square root of 33 is going to be, we're going to say it's 5.7. So you're going to have 17 plus 5.7 over 32. And then you're going to have 17 minus 5.7 over 32. So over here, that's going to give you 22.7 over 32, which is going to be equal to we're going to say 7.1. All right, so under 1 second, all right? And then 17 minus 5.7 is 11.3. Divide that by 32, and you get 0.35. All right? And so the times we're talking about, apparently this thing takes off pretty quick and comes down pretty fast. All right, so 0.35 seconds, and then later on at 0.71 seconds.